Okay, so now we're going to do a real, like, legitimate program. And so here's going to be the plan. We're going to make an int array, and the first thing I'm going to do is I'm going to allocate like 100 ints. And now I'm going to allocate pointers to pointers. And note I did size of int star there times 4. And so here's the setup I'd like to have. Let's see. Okay, and so I guess, let's see, this is only 30, so let's just make this be 30, so it's like an exact match. Meaning my ASCII art is an array of size 30. And so this would be address 0, 1, 2, I'm sorry, that's not correct at all. They're not addresses. This is the location of x0, x1, x2, etc. And unfortunately, I don't have the space in there, and so really when I say x0, I mean that. And so let me just put in here 0, 1, 2, 3. That'd be 4. So let me write an x4 right there, right? So x4 is that one, and x0 is that one, and so on. And this one right here would be x8. And so I've set up, now I've allocated 4 pointers. And by the way, x has some address, and let's just assume that this returns the address of, like, 0x1000, right? But it's something, okay? And y has an address too. And we could try to guesstimate it. We could say, oh, we've allocated 120 bytes, and if we go to address 1000, well, 0x1000, the hex address, we could try to add 120 bytes and say 1000 plus 120 is this. We predict that'll be the address. That may or may not be true. Malloc could give us addresses from anywhere. So, let's just assume that this address is like 0, I don't know, 2000. It ended up being really different. That's fine. And so here's y, and I apologize, but I'm going to draw y differently. And so y0 is, what? How do we think of it as y0? And the address is going to be, in our made-up example, is going to be 0x2000, and then since it's 8 bytes, so now those are the addresses for y. And so here's the thing, is I can go and I can say y0 equals x, and that's fine, because x is a pointer to an integer, and y0 is a pointer to an integer. So y is a pointer to an integer. So y0 is a pointer to an integer. So the types here match, right? And so what we've done is we've set up an array of 4 pointers, and that's why I've drawn it this way. So I could, for example, say y0 is that. And so now we've allocated 4 pointers as an array, we've allocated 32 bytes. And through the type, we are choosing to interpret this as a pointer to an int. But once we start using this syntax, we're saying we're treating this as an array. So now it's an array, and we know since it's 32 bytes, the last address we can access that we should access is y3, because we started talking about y4. That's 32 bytes past, and we're going to hotel rooms we have no business being in, right? And so this is saying we're treating this as an array, and for these addresses, we're filling up the values as x and x plus 4 and x plus 8 and so on. So if x is at 1000, then now the values for y0 would be x, which is 1,000, and for y1 would be x plus 4, and int is 4 bytes. 4 times 4 is 16, so we would get that, and we get a situation like that. We're now at y0, y1, y2, y3. We're getting the values that correspond to x0, x4, x8. I'm sorry, the addresses, the locations of x0, x4, x8, and x12. So now, let's do this. And if I say I'm going to initialize this, xi equals 0. And now if I start going down, and I can treat this as a two-dimensional array, I can say y0 of 3. And what that would do is it would go to y0, which is at this location, and would find its value. Its value is 1,000. And we'd say go to address 1,000 and go 3 over. So in this case, y0 is the same as x. I don't even need to put the parentheses, like that. So y0 resolves to x, and so y03 is like x3. Now where it gets a little trickier is if we say like y3 and you know, whatever y32, then this would be the same as y3 points to the address x plus address 0x 1030, right? That's y3, which is the same as x plus 12, which is the same as x14. So if we were to go now and just for example say y3 2 equals 100, and print out x, we'll find that the 14th entry, I think, or we're going to have a terrible video, is 100. Actually, probably the 13th entry. There's probably some zero index issue.
One of them would be 100.
Well, hopefully it's one that we can reason about and say this is why it is, right? Yeah. Okay, tells us we didn't have a printf. Good, and it was 14, right? And so now there's two, okay, let me stop here because I think this actually worked out. I'm always in fear that I'll lose the video or I'll make a mistake and lose the whole video. So I'm gonna stop this one.